here we go. I'm in number 2, right? Am I still in number 2? Yeah? Okay. So, that's 2. Now, what's that yellow mean? What type of a block? P. Okay, how many is the maximum amount of electrons you can have in a P? 6. Okay, so what if I put a 2p6 there? What atom would I be on? Neon. Neon. Okay, well what if I put a 2p5 there? What atom would I be on? Fluorine. Do you see that? Okay, what if I put a 2p3 there? What atom would I be on? Nitrogen. 1, 2, 3. But I need a 2p what? 4. Okay, that's my oxygen. Now, let's take a look at this right here. 2 plus 2 is 4, plus another 4 is what? 8. That had better match up, right? If it don't, we've done something the matter. All right. Let me do one more. Let's do sodium, then we're going to open up the floor here to get anything resolved if we can. Okay, the first thing is we're going to start in the top left-hand side, and that's going to be a 1. And my finger will pass through the S. So that's a 1s2. Okay, here, what comes next? 2s2. Then what comes next? 2p6. All right, what atom am I on right now? Neon. See, I'm way over here with neon. Back again, I'm in the 3s what? 1. So let me draw up sodium for you and show you what that looks like. All right. So here's what we got for sodium, because that would be a neat little thing to draw up. All right, here we go. We got ourselves a hard nucleus, and then we've got ourselves a little bitty ball there. Now, how many electrons does that little bitty ball have? 2. Now I've got myself a big ball, like a beach ball. How many electrons does that have? 2. Now I've got p orbitals, right? You guys are going to love this one. So I'll draw up the p orbitals. Okay. Now here we go. Here's my px, py, pz. All right, what does that look like? A little flower? All right, flower power. All right. And then what? How many electrons are in that? 6. So we're going to put 1, 2, 3, 4, 5, 6 in there. All right. Now what comes next? All right, another big circle. And how many electrons has that got in it? So where's the chemistry going to happen? Right there. It's not going to be happening inside this core right here. All right. So if you was to get down and look at this sodium atom, that's what you would see. Now actually how atoms really look, if you could really conceptualize it, there's a little dot, and then it would kind of just look like a little busy beehive. Okay? Where you could see all these little things moving around, but it's so busy and you can't really tell what the hell's going on, but you can kind of see something moving. That's what an atom really would look like, because this is happening so quickly. But as far as room designations and orbital notations, this is where it's at. Okay. Who wants to ask me questions? Yes. Oh, no. No, I'm just drawing this. See, what you're going to do on your test is to give this notation. But what good's that notation going to do if you cannot picture what's really happening? All right. No, I don't have you draw on a test personally. Yes, somebody's got a question back here.
I guess the 1s to the 2, from the 2 to the 2p6. That's what
You're stuck where now?
because I get the 1s2. That's like the first.
Yep.
Yeah, the first one, and then it's an S block, and then there's maximum 2.
Yep.
And then
Now we're at 2. We're passing through the S block, right? So that's got a maximum of 2. And now we're still in number 2. All right. And now in the P block, which has a maximum of 6. All right. Yeah.
How come the H is yellow?
How come what now?
How come the helium is yellow?
It's a weird example. Helium, that's a good question. Helium is yellow, but it is not considered a P block. It's the only thing up there that's pathological to what I told you. Helium is just a 1s2. That's its electron configuration. There's no p orbitals in helium. All right.
We have to go back to like ones that have the no electrons, no stuff you're talking about yesterday, where it doesn't have like one missing like an electron.
Oh, like an ion? Yeah, we'll get to that. Yeah, but not right now. All right. Does anybody have any other questions? Can you handle a couple?
District,
Huh?
how did they come up with S and P? Why did they choose the letters like that? S and P? They're not even alphabetical.
I have been asked that, and I do not know. I've tried to look historically at that. You know, there was even somebody told me one time that the S looked like an S because it was a sphere, and the P was a P because of it looked like a peanut. But I'm going to tell you right now, I don't buy it. All right. Now, that could have happened. I don't know, you know. But I've looked. I really don't know. It's just like, you know, like a dozen. How many things are in a dozen? 12. So people have asked me before, well, where does that number come from? Where does that come from? Does anybody know? I mean, why pick the number 12? I mean, I don't know. I've had people tell me, well, the reason they did that was because in the Bible there were 12 disciples. And that would make people think about the Bible and Christians and Jesus and all this, so let's just keep the 12 there for everyday life. I can't disprove that, but I don't know where it comes from. You know, I don't know. I have no clue.
I heard this is like the English measure, forms of measure from.
It could be, yeah, like whale, like stones and stuff that they used to measure with. I don't know. All right, are you ready to try a couple? Am I drinking my drink instead of your drink? All right, are you guys ready? I don't know, I may like what you guys are drinking more. Okay. Let me pick a couple for you then. Why don't we try to do sulfur? Why don't you guys try nitrogen and try calcium. All right. We'll turn off the camera, let you guys get amongst yourself.